Time is not a straight line. It loops, it hides, it remembers, buried beneath sands, written in forgotten scripts, encoded in the stars. They never wanted us to find. This is eternal vault, from the lost world of the ancients to the future we are not yet ready to see. You're not just watching a video. Let the vault reveal everything. 634 individuals have flown aboard the International Space Station since its inception. Astronauts, scientists, even tourists. The world cheers, celebrates them as space travelers. But here's the question: have they really been to space? At first glance, it may sound absurd to even ask this. After all, they orbited the Earth at 400 kilometers above sea level, floated weightlessly, and saw the blue planet from a vantage point few will ever experience. But if we dig deeper, scientifically and philosophically, we discover a perspective-shifting truth. This video is not to undermine the achievement of those who've been to the ISS. Instead, it is to humbly explore what we actually mean when we say space. Let's begin with a fundamental question. What is space? Scientifically, space begins at the Karman line, an imaginary boundary located 100 kilometers, 62 miles, above Earth's sea level. This is the internationally recognized standard adopted by the Fédération Aéronautique Internationale, FAI. Some organizations, such as NASA and the US Air Force, have historically awarded astronaut wings to those who crossed just 80 kilometers, 50 miles. So yes, by all modern standards, ISS lies well within space, as it orbits between 408–420 kilometers above Earth. But let's pause. The word space evokes vastness, emptiness, detachment from Earth, an alien untouched void. The ISS, however, orbits in what's known as low Earth orbit, LEO. It's still very much under Earth's influence: gravitational, atmospheric, electromagnetic. So, is being there truly space travel, or is it just a higher viewpoint from our planet? Let's try a simple thought experiment. Assume your height is 6 feet, roughly 1.8 meters. While standing on Earth's surface, the furthest you can see due to the planet's curvature is about 4.8 kilometers, 3 miles. This is your horizon. From that vantage point, you can visually cover a surface area of around 73.2 square kilometers if you look in all directions. Now imagine you're magically lifted to the top of Burj Khalifa, 555 meters high, the tallest structure built by humans. At this altitude, your horizon stretches to 84 kilometers, and you can see 22,219 square kilometers of Earth's surface. That's roughly the size of New Jersey. Rise further, to the summit of Mount Everest, about 8.8 kilometers up. From there, your line of sight extends up to 336 kilometers, with a visible area of 354,332 square kilometers. The higher you go, the more of Earth you see, but it's still Earth. Now let's rocket upward, 400 kilometers above the Earth, where the ISS orbits every 90 minutes. From here, your visual horizon extends to a jaw-dropping 2,257 kilometers in every direction. The total area you can observe at any moment is over 15 million square kilometers. That's nearly the combined area of Russia and Canada. And yes, from here, the Earth curves below you. You see the blue oceans, white clouds, the slim atmospheric layer, and a backdrop that shocks many first-time astronauts: pure black sky. Here on Earth, the sky appears blue because of a process called Rayleigh scattering. Molecules in our thick atmosphere scatter shorter blue wavelengths of sunlight more than red. But at 400 kilometers altitude, the atmosphere is extremely thin. There are far fewer molecules to scatter light. The result? Even when the sun is shining brightly, the sky appears black. This phenomenon isn't evidence that you're in deep space. It just means you're above the layer where significant scattering occurs. This change in environment creates a visual illusion that you've left Earth completely, but scientifically, you're still well within Earth's grip. Let's address another popular misconception: weightlessness. Many think zero gravity is a feature of space. But here's the truth. Weightlessness is not due to a lack of gravity. In fact, the Earth's gravitational pull at ISS altitude is still about 90% as strong as it is at the surface. So why do astronauts float? Because they, and the ISS, are in continuous freefall. The space station is falling toward Earth, but it's moving forward fast enough, about 7.66 kilometers per s, that it keeps missing the planet. This constant state of falling around Earth creates the sensation of zero gravity. So technically, you can experience weightlessness without going to space, in parabolic flights, in elevators during free fall, even in theme park rides momentarily. Weightlessness is a condition of motion, not of location. Let's visualize this differently. If Earth were the size of a classroom globe, about 1 foot or 30 centimeters in diameter, the ISS would orbit just 1 millimeter above the surface, about the thickness of a human fingernail or a strand of hair. That's how close the ISS is to Earth, even though it feels far. This simple model emphasizes that low Earth orbit is still tightly bound to Earth, gravitationally, atmospherically, magnetically. When astronauts look down from the ISS, they see a beautifully curved Earth, the famed blue marble. But even that has limitations. What they're observing is only a small slice of the planet, a circular cross-section. It feels like they're seeing the whole Earth, but the brain fills in the missing parts. It's the observer effect, where your perspective influences your belief about reality. Just because it looks like space doesn't always mean it is space in the full cosmic sense. So let's ask again, is the ISS really in space? Let's break it down. Scientific, FAI, NASA, yes, above 100 kilometers and 80 kilometers. Public perception, yes, astronauts, black sky, weightlessness. Philosophical, exploratory, no, still under Earth's influence. Cosmic view, no, not beyond cislunar space. If we consider space travel to mean detaching from Earth's sphere of influence, traveling to the Moon, Mars, or beyond, then LEO missions feel like just the beginning. Think of ISS missions as near-Earth orbit excursions, not true deep space journeys. True space travel might involve going beyond Earth's gravity well, crossing into interplanetary space, surviving solar radiation without magnetic shielding, relying on onboard life support and navigation, without Earth's constant help. The Apollo missions, for instance, are considered true space journeys. Their astronauts went to the Moon, outside Earth's magnetosphere, exposed to solar radiation, navigating with limited help from mission control. Upcoming missions to Mars, Europa, and deep space exploration will truly embody space travel, in risk, distance, and independence. The ISS is a miracle of engineering, a science laboratory in microgravity, and humanity's longest continuously inhabited outpost in space. It's an amazing platform for studying the effects of long-term spaceflight on the human body, understanding fluid dynamics, combustion, and biology in microgravity, testing life support systems for future deep space missions, conducting international collaboration across space agencies. But it is not space travel in the interstellar sense. It's preparation, a launchpad for real spacefaring civilization. The ISS is many things: inspiring, majestic, educational, but it is not deep space. It is a distorted point of view, a new way to look back at ourselves. It gives us perspective, not escape. Understanding that difference matters, not to belittle the achievements of those aboard the ISS, but to inspire future generations to go even further, to the Moon, to Mars, to beyond the solar wind. Because space, real space, awaits. It's not space, buddy. It's a distorted point of view that gives us a new way to see the world.